All right. Good evening, everyone. So let me click on YouTube so that we can see the charts. Okay. Please let me know if you can hear me clearly. All right. Let me know if you can hear me by saying yes on the chat. All right. Thank you very much. So let me share my screen and then we can start. Okay. I'm trying to off my camera and then share my screen. Sharing my screen already. Okay. And let me close my WhatsApp. Click on VS Code to open my Jupyter Lab notebook for Pandas 4 or so. See 4. Okay, that is okay. We have done Pandas 4 yesterday, and I think today we'll be looking at exploratory data analysis in Pandas 5. But before we move into 5, let me open 3 so that I can summarize what we learned yesterday. So yesterday, we looked into how we can recognize missing value in our data, okay? And we can use I'm sorry, it's my baby. Guy, I'm in a meeting. Okay, please let me know if you can hear me again. Okay, so let me see if you can, let me know if you can see my screen. I can't see my screen myself on YouTube. Okay, I think it's loading now. All right, great. So yesterday, we looked into how to undo missing data in a data frame. And to detect a missing data in data frame, you will use is NA or is null attributes. And then to summarize the number of missing values per column or variable, you will use is null dot sum. So that will give you the summary of missing values per column. Okay, and we also look at how you can impute for missing value in your data frame. For example, yesterday you saw how to impute by mean, right? And you also see how you can impute by a given value. For example, you may want to say wherever there's missing value, that missing value should be turned to 0. Okay, some people used to do that a lot because they don't want to affect their data maybe they don't understand the kind of distribution their data is following, so they don't want to use the mean or median or any given imputation. So they just want to identify the missing value by zero. So it's also possible to do that. Of course, yesterday I did not show you how to just impute a particular value for your missing value, and it's very easy. So to do that, right, what you just do is here, for example, let's say that you want to fill the missing value by, let's say, zero for both height and width. You just come here and put zero here. So instead of having Somalia woman dot mean, you just put zero here, and wherever there is missing value, so that zero will replace those missing values. So we look at this yesterday, and thank you so much for following it. And then we also look at another, stage of data cleaning, which is checking the duplicate in the data frame. And we recognize duplicates wherever a certain observation is repeating itself, right? And I've told you several reasons why you may have a duplicate in your data. And we saw how to identify duplicates in that data. For example, you will use something like this. Let's say this is data frame, the course attendance, and to identify missing value, you just put the dot duplicated in the index, okay, and that will show you the missing value in this data frame. All right. And of course, you can also identify duplicate by a given column. So in that case, you just put that column here instead of it being empty. You just put it here, and the duplicated rows will show up here. And I told you that whenever you use the duplicated, all the where the data repeated is not what we see here. It will only show you where duplications have occurred. For example, if my name is Ezekiel Ogundepo, my Ezekiel Ogundepo, right? You will not see Ezekiel Ogundepo twice. You only see it once, except if Ezekiel Ogundepo occurs more than 3 times. That is when you will see Ezekiel Ogundepo in 2 times in the duplication. Okay, for example, I just try to create this data, so you may not have it in your own. Of course, you have it in your own, but when I was reviewing what I taught you yesterday, I saw that I did not explain it. That's why I have to put it here. You can see here in the data we have where is it? You can see it here. Ibrahim appears here. Ibrahim appears here. Ibrahim appears here. Ibrahim appears here. And Ibrahim appears about how many rows? 1, 2, 3, 4. About four rows. But in the original data, right? Is it Ibrahim appears 5 times, but duplication is just where it is extra, not the total Ibrahim, but where it is extra. So you can just call it n-1, for example. Okay, I can see, you can also get duplicate by that given columns. Here we have name and country. And yesterday I did not show you how to actually remove duplicate entirely. Okay, so today I'm going to quickly show you before we move to the next stage of data cleaning. Now, to remove duplicates, you will use drop underscore duplicates. So the attribute to use to remove duplicate your data frame is dot drop underscore duplicates. Of course, you remember what in place is equal to true. So who can tell me what in place is equal to true means on the charts? Who can tell me what in place is equal to true means on the charts? Okay, I'm not going to wait for you to say it if you don't want to say it because we don't have time. Of course, you know what it is already. So now this drop underscore duplicate will remove the duplicate entirely. Now you can see that from the original data frame, we have about 20 rows. And when we remove the true duplicates, we now have the data frame remaining 15 observations. So that is how to remove a duplicate in your data frame. So today we'll be looking at exploratory data analysis. Let me screenshot it. So what is that? What is the meaning of exploration? Somebody will tell you, go and carry out EDA on your data. Go and carry out EDA on your data. So what does EDA mean? So EDA is just a way, to analyze your data so as to understand what is going on. And you actually do that by summarizing the main characteristics and by using visualization method. So you do exploration data analysis, by exploring your data in form of creating visualization and table. So this will help you to be able to be familiar with your data. Okay. So today we'll be seeing several exploration data analysis method that you can carry out with your in your data sets. So we'll be looking because we are in Python, we have some packages which can help you to quickly, summarize your data. One of them is Pandas profiling. And of course, before you can use Panda profiling, you have to install wide data profiling module. And this is how to install it. Okay. So remember to install it when you are in case you are on VS Code, you just click on terminal. Okay, click on new terminal and put the code here. That is pip install y data profiling. And when you are doing that, make sure that you have enough data on your either on your phone or in your computer. Make sure you connect your computer to the internet and then click on enter to install it. Okay. Of course, installing a package or module is not always easy. Sometimes it will upset you a lot. So just find a way to install it. If two or three people could install it, then there is nothing stopping you from not able to install it. Just find a way. That was why I was asking some people on the group to to use ChatGPT. What is their error? Go to ChatGPT, go to Gemini, go to which one again? Many other LLM, because as a programmer you will face a lot of problems in terms of error, in terms of debugging and many things like that. And you cannot, it's not every time you'll be calling people or asking people to help you with your error. Now we have something that God has given us in the world to help us makes life easier, and one of them is ChatGPT. I remember when we don't have ChatGPT, you will go to Stack Overflow. Sometimes I will post the error message on Twitter. We have Twitter community that will help us look at it. But now we don't call anybody again. So just know how to read the error message. It could be that it's telling you to do something. For example, dependency modules. For example, let's say for example, let's come to Christianity, for example. Before you can go to before you can go to God, you have to come through Jesus Christ. Jesus said, I am the way, the truth, and the life. And nobody will come to the Father except by me. So you want to know God, but you don't want to come through Jesus Christ. You can see that you are not doing well. So that's the same thing with installing modules. Modules may have some dependencies. And this thing will throw an error telling you something supposed to be installed before this. So if you don't just read the message and you are just copying your code and sending to the WhatsApp group, then nobody will be able to help you. Of course, if you have tried your luck, try your best, and it's still not working, in that time you can start, looking for help. But before you can start, asking people for help, make sure you also do something. Read the error message. Go, put everything on the error message. Put to ChatGPT. If I show you how I used to do my work, you just be There was a time I worked with, don't let me mention, it's an international company, and throughout the project, it's me and ChatGPT, and that's all. So please, the same thing you will also be doing. If you want to become a good data scientist or machine learning engineer. So imagine you have installed this wide data profiling, right? So to be able to use it, you need to import it as from wide data profiling, import profile report. So what you want to do there, this one here, you can see here, is what we need to help us visualize our data. Then you just run everything. As you can see, it's running. You can see that uh, everything has run. Okay. Now, today we'll be looking at several data that we want to perform exploratory data analysis with. So the first one is Ethiopia flower, and I'm going to read it from the dataset directory, as you can see. So now I have loaded this, and you can see that it works. To know that it works, I can actually call for the head attribute on this Ethiopia flower data. So let me uh, create a new cell and see Ethiopia flower dot head. Okay, so you can see now that we have separate length, separate width, separate weight, and species. I've told you that I tried to localize the data set. The original data set is from Irish data sets, right? And because of the project we did that time, I tried to, because every time I'm teaching, I always like to bring the context back to the how will I call it, back to the local roots, so that you can easily understand what I'm saying. That's why you see me quoting Bible, and I'm happy that I'm teaching the people of God. If I'm teaching other people, I will not even quote the Bible. Okay, because of their rules and regulation. The incubator hub too, they also have their rule and regulation that we must try to obey. Okay, so yeah, in this place here we have carnation, we have lily, and so on and so forth. Okay, so now to apply panda profiling on this, what you just do is to apply the profile very well. Now you can see it is summarizing your data, and it will do a lot of activities on this data so that you can understand it very well. Now you can see now. You see, based on what we have, you can see the number of variables. You can see the number of missing cells, that is missing values. You can see the duplication in this data set. You can see that now I have about 95 duplication here. All right, you can see the duplication row in percentage. You can see the variable type that we have, 4 numeric and one categorical variable. And then the variables, under the variable section here, you can just start playing with. You can see if this one is doing it per variable analysis. So if you select any column, okay, for example, I selected separate length. You can see the distribution of separate length here. You can see the distance value. You can see the histogram. You can see that here looks like it is symmetric in nature. You can see the main of the variable. You can see the minimum, maximum. So this one will help you to understand your data very well before you start doing any data science or machine learning in it. And then you also have some interaction. This one is plotting a scatter diagram for you. And you know that before you can plot a scatter diagram, you must have two continuous variables. So here you can see the petal weight, you can see the petal length, you can see that here is there's a linear relationship between petal weight and the separate length, right? You can also click on this one too. You can see here peta weight and sepa weight. You can see the kind of correlation, in them. And when you look at the correlation stage here, you can see the heat map, right? So this is the, if they ask you what is heat map, this is just a heat map, right? Showing you the correlation between those variables, by using this heat map chart. You can see this is the what do you call it now? This is the values of those correlation. For example, wherever it is like dark blue here, it's telling you that it has higher correlation. You can see it here. Of course, we don't see it numerically, but here you can see that this one here, peta, because peta length and peta length is the same variable. Of course, that correlation will be 1. That is why you can see the darkest blue here. Okay, and that is that. You can also click on table. So this is the correlation table, right? If you cannot quantify the correlation coefficient in this heat map, then you can move to the correlation table to now see everything numerically. So here now you can see that peta length and peta width are highly correlated. You can see 0.932. The same thing here, and you can see peta width, sepa width, and peta length is minus 0.28, telling you that there's a negative weak correlate, because this is not up to 5. So here it's telling you that sepa weight and peta length are negatively correlated. Okay, and now look at the missing value. You can see that there's no missing value at all because the data has 350 rows. You can see everything is completed. All right, now here is the sample. Who can tell me what this one means? Who can tell me what this one means? The first row, the last row. Who can tell me what this one means? Who can tell me what the first row and the last row mean? What is the alternative to get this one? Anybody? Okay, exactly. Thank you, data evangelist. This is just the same thing as using your head and tail. All right. Now you can see that this panda profiling is actually doing a lot of things for us. Right? I think that it can take us some hours. In data science, they said that about 80% of your time, you will always do it in cleaning your data and doing exploratory analysis. So what could take me 80% of my time now, this guy, panda profiling, has quickly done it within 5 seconds. You can see now. So this is, and it's not using any AI. Okay, you can see, and it work without internet. You can see if there's any duplication row. You can see here we have it's telling most frequently occurring. So I think here at the duplication, okay, it's telling you that this duplicate number at the, maybe this one is appearing 9 times, 7 times, 7 times, and so on and so forth. Okay, and that's all. That's all. That's all. From pandas profiling. Any question? Thank you, Irene. You can see it's very simple. So the same thing I'm going to apply here. So this data set is from Kenya, is from Uganda, Somalia, Kenya, Ethiopia, Sudan, Tanzania, and Rwanda. If you are from Kenya, can you say yes? That's my country. If you come from Kenya and you are yes, can you type it on the chat? Say, oh, I'm from Kenya. If you are in another country that is not Nigeria, can you recognize, by putting your country on the chat? For me, I'm from Nigeria. Anybody here? You are not from Nigeria, can you type it that I'm not from Nigeria? If your country is here, say yes, that's my country. Okay, so okay, we can see Estonia. I can see somebody from Lagos. Thank you, Samuel. Okay, so I'm happy. At least Charles is from another country. Thank you. Okay, Sylvie is saying that it could have come from Kenya. Okay, okay, we have Olakpeju from South Africa. Okay, okay, we have Yola. Yola is in Nigeria. We have somebody who's in Nigeria that was currently in the Ukraine. Thank you so much. Oh, I can see Michael from Gambia. Thank you. So now you can see here, this is just like how we, transfer money from one country to the other. So this data is inside your data set directory. And if I put the profile report on it, I will get everything I need about this data. So once you have carried out the profile report on the data, okay, you understand where the data has a problem. From there, you can start knowing this guy will not clean the data for you. It will only show you something about your data, what you cannot see by yourself. Profile report will show it to you. Just like if you have not born again, right? The Holy Spirit will be reminding you every time that it is now up to you to repent of your sin and then come to Jesus Christ. So that's exactly the Holy Spirit will not repent for you. It is you that will repent by yourself. Okay? So that's exactly what's happening here. You can see that the data has about 10 variables, 500 observations, duplicate rows, 153 rows, and we have about 4 numeric variables and 6 categorical variables. So now you can understand the data with just with that. Okay, now if you go into the variable one by one, you can see that gender, we have 2 distinct gender and they are just female and male. And you can see that a lot of female sent money more than male. Okay, so that is just your little statistic that you can actually make from that. And then we have the age column. You can see the minimum age is 18 years old. Of course, we don't expect less than 80 to be sending money to another country. We have maximum, this is 70 years old, it's grandpa now. Okay, here is the mean age, the average age is 38. Of course, this is around the working age between I think 18 to 65, if I'm not mistaken. Okay, now you can see we also have another variable called direction. Is it inflow? Is it outflow? Okay, and then we have transfer, the amount they are transferring. The minimum will be maybe one. I don't know the currency that I use for this data. I actually generated data by myself. Let me see. I can't remember the currency. Okay, because it is international. Okay, maybe let make it dollars. Okay, let's make it dollars. And yeah, so you can see under the amount, you can see the minimum is $1, the maximum is $99. And you can see that we have the average transaction is $51. Okay, now you can see several currency at which they exchange. This is ETB. This one is, I think this is Ethiopia. I don't know. This is, I think this is Tanzania. This is Kenya. This is Rwanda franc. I don't know this one. Okay. So what kind of device are they using? Is it devices are they using? Is it smartphone? One is yes and zero is none. Okay. Where are they? Urban is one, rural is zero. Transaction duration. How long does it take them to transfer the money? You can see the minimum is 0.14 minutes and the maximum is about 99 minutes. Okay, the mean is 50 minutes. You can see. So that's if OPay or Money Point, get access to this kind of data. This is how they now invade Nigeria by trying to become a money transfer organization. You can see that they are very rich now. So this kind of data will make you rich if you know how to solve a problem. Imagine it's taking you about 15 minutes to be able to send money. You can see that's too much, right? Now, GOW, this is the day of the week. You can see that people like to send money on Sunday than other days. So this kind of the interpretation that you can get from here. And this is the correlation, for each variable. Okay, and here is the correlation, each map, and this is the correlation table. All right, I can see that here there's no missing value. Everything is complete, and this is the first observation, uh, the first 10 observations, and here is the last 10 observation. And here are the duplication. You can see where duplicates appear. Instead of using is the duplicate in your data frame, this actually does everything for you. Okay, and that's about that. Any question? I believe everything is interesting, all right? Any question? So any question? Yeah, exactly. So why data gives you everything you need instead of doing it by yourself. That's it. That's it. So I haven't been able to import my white data. So just find a way to do it. Nobody will help you. You need to help yourself in this matter now. Okay. So everything is interesting now. All right. So now, of course, why the profile Panda profiling is actually good. Sometimes you may want to summarize your data by yourself or by computing descriptive statistics. So if I ask you what descriptive statistics is, who can tell me the definition of descriptive statistics? This, so we have two types of statistics. The first one is descriptive statistics, and second one is inferential statistics. What is the difference between EDA and the main data analysis? So I'm going to answer that one. So EDA, exploratory data analysis, helps you to explore your data. It gives you the summary about your data. The data analysis is giving you the insights. You'll be able to answer questions with your data analysis, but you cannot answer questions with your EDA. For example, if I want, the kind of question you may ask is, um, why is it that some people are not using smartphone in carrying out their transaction? EDA will not, with EDA, you cannot know that one, right? Of course, you can see that people are not using more of smartphone in carrying. You can see here, where is it? You can see we have 232 people that use smartphone to carry out their transaction, while many people did not even use smartphone. So EDA will not answer that question. It is your analysis. You will start, digging into the data to be able to answer such a question. All right. But if your boss asks you how many females do we have in the data, of course you can easily answer that one with EDA. Okay. Data analysis give useful information. Thank you. Nobody's wrong. You are not wrong. Statistics that have to be defined before they are obtained or gotten from a data set. Okay. Main media mode ECT is the descriptive. No, it's not only main media mode. What about variant? What about standard deviation? So descriptive statistics helps you to summarize your data in form of a table and chart or map. Okay, so that is what descriptive statistics is doing. When you create a table, when you visualize your data, what you are doing in that level is called descriptive statistics. But when it comes to because of our time, don't let me waste too much on statistics. Okay, you know, if I start teaching statistics, I'll just be going on and on like that. Okay, so let's continue here. So here we want to see how we can actually do those discrete statistics, by ourselves. So remember, we are using Somalia women dataset here. And of course, we've seen how to use describe method. Describe method actually gives us the description that we're talking about to summarize the data by using central tendencies such as the mean, the median, the mode. Of course, what this one actually does is called in statistics, we call it five number summary. Okay, five number summary is your mean, your maximum, your mean, your median, and which one again? Your first quartile, your third quartile. Okay, so that is exactly what your five number summary is doing, and that's exactly what this guy is doing. Okay, so in the five number summary, we have our mean. You can see here we have the first quartile, we have the median, we have the third quartile, and we have the maximum. So from year to year is what you call five number summary. But this describe is also helping us to understand our mean and understand our standard deviation and to know the number of observations that we have in our data. Okay, so you can see now that we can easily get a little statistics about our data here by looking at the height and the weight. Okay, so the same thing we can also do by using the East Africa data. In this East Africa data, we don't have continuous variables. We only have everything in can we call it a categorical variable? Of course, yes. Gender is a categorical variable because we cannot quantify it with number. Now, you are a male, I'm a male, you are a female, okay? You are not better than me, and I'm not better than you, all right? So that's exactly what categorical variable is all about. You can only put them into category that they belong to. You can only put them into a particular label. They label me as a male. The same thing, they label you. For example, who is a female here? We have Elizabeth here, who happens to be a female by default, and that is how the label are. Okay. Now, let's say when you apply the describe here, you can see that describe it's not giving us any mean, it's not giving us any median, it's not giving us any standard deviation. What the describe is giving us on the categorical variables are just your number of observations, one, and then giving us our mode. You can see the top. The top is the mode. You can see for this one here in the East Africa, if you go to the East Africa, the common name maybe ambassador. According to this data, you can see an ambassador is a male. You can see, and it appears three times in the data. And this ambassador, is from Amharic. You can see the first origin is Amharic, and Amharic, is actually from I think Ethiopia because they spoke Amharic in Ethiopia. Another origin that this guy where this name can be found is Indonesia. Okay, and you can also see it in Somalia. All right, that is how this interpretation can be. The sweet again. No, please, can we just take it slowly to follow effectively? Uh, yes, of course, I'm not fast because this thing you know it already. I have been given the information. Many of you are just coming here to learn everything from the first time, which is fine. If that is your method, is fine. But we have to complete the pandas today so that we can move into visualization tomorrow. So wherever I stop today is the end of pandas. Otherwise, you can take your time to read the script by yourself. Okay, if you still want me to slow down like that, I can slow down. But just know that we may not cover all these pandas. Just take your time to read the script. Everything is clearly described here, so you can read it and understand it. So we have this data set called registration data frame, and I believe you have seen it before, where we have gender, country, and age. And now, let's see, we want to understand the distribution of gender. Okay, we can use the describe there. From there, we will know the mode for gender. You can see it is female and it appears 6 times. You can see it appears 6 times. Okay, and when you use dot describe on registration data frame, what it will do is that it will throw away the categorical variable and then only work with the continuous variable so that you can have all your 5 number summaries in addition, to the standard deviation, a mean, and a counts. And I believe you understand it now. Then we now have, sometimes you may want to understand the frequency distribution of your data. Somebody may ask you, can I get the statistics of those people that actually pass the data science and machine learning in terms of their gender? Okay, in this case, you will need to, because if you start giving them the student statistics, right? This one you only see the main, you will see the everything about continuous. But somebody wants you to give them in terms of the actual number. If possible, you attach percentage to it. So, and that's exactly what you want to do here. And you can do that by using the value counts method. So when you apply value count method, it will show you their table or their statistic. For example, you can see how many females, there are 6, how many male, there are 4. You can see. So this is how to create exactly. Thank you. We are dealing with univariate analysis. Univariate analysis is when you are dealing with only one variable. We have bivariate analysis when you have two variables, and we have multivariate analysis when you are analyzing many variables, at the same time. And of course, this kind of univariate analysis, there are some certain charts or graphs that are suitable for them. For example, when you are plotting charts for gender, I would not like you to use histogram. Okay, why? Because histogram is for continuous variable. So you must understand the distribution of your data before you start, plotting. Okay, when you this one, which is categorical variable, of course, you can use a bar chart, you can use a pie chart, you can use a donut chart. Okay, but when it comes to the continuous here, okay, in this case, for the age, for example, I will not like you to use a bar chart. Reason being that bar chart is only useful when you have a categorical or a discrete variable. And I said discrete variable. Yes, discrete variable when you have the values and they are not many. I mean, the maximum for bar chart, if you want to apply a bar chart, should not be more than what is it? Should not be more than 5 in terms of the value. For example, imagine you want to plot the state of origin in Nigeria. I mean, state of origin. Yes, of course, yes. We have Hausa, Yoruba, Igbo. The major ones are those Hausa, Yoruba, and Igbo. But if you start counting all of them, we have more than 54, more than that self. Let me Google it. How many state of origin do we have in Nigeria? How many, is it ethnic group rather? How many ethnic group? How many ethnic group do we have in Nigeria? Okay. So here we have about 250 ethnic group, Hausa, Igbo, and Yoruba, and so on and so forth. So you can see now that such a case you cannot use a bar chart. So for this one, I would like you to use something like a box plot, something like a histogram, something like which one again? Box plot, and these are the most common ones that you can use for the continuous variable if it is univariate data. Okay. Now let's see how we can actually, represent all of this in then count plot will do. So you need to understand it that count plot is the same thing as your bar chart. Okay, it is just when we get to Seaborn that they start using different name. Okay, so if somebody has not used Python before and you say count plot, they will just be saying that you are not a good analyst. It is somebody who developed Seaborn that started giving other names like that. Okay. So we have to create a percentage, right? So what we do is just to use this argument, or parameter. So just say normalize is equal to true. Okay. When you say normalize is equal to true and you run it, it will give you the proportion of those values. You can see for male it is 0.54. But to be able to represent it with percentage, you just multiply it by 100. And by that, you can have something like this. You can see that the distribution of male is 54%, and that of female is 45.5, 45.6%. And that is how to do that. And sometimes sort it in ascending or descending order. Okay. So to do that, you are going to use this parameter called sort and say sort is equal to true. So this will now help you to arrange your data in descending order. You can see that the male is 54% and the female is 45.6%. Okay, and I think that is what I have for Pandas 5. Any question? Any question? Okay, let's move on. Okay, so let's move on. Right. The other one we'll be doing here is, yeah, this is very, very important, where we are dealing with a group operation. So what does group operation actually mean, right? For example, we have, let me use this one so that I'm not using other example. Yeah, look at it now. You have your student data, right? And you have this gender, and you have their score in mathematics to be all of this. Okay. And somebody is asking you that what is the average of female and male performance in mathematics. Okay. You can see before you can do get their performances, you need to group the data so that you can analyze the data for female and then the data for male. When you group the data like that, then you'll be able to summarize those data by group and get the results. And that is exactly what group by operation is doing. Okay, so by group by, we mean that we split the data by a given variable. In this case, it is gender, and then we now apply our statistics on it. So the statistics could be the mean, it could be the sum, it could be the variance, it could even be you under getting the number of female and the number of male in the data. Okay, so let's see an example. So I'm going to import my data. Okay, you can see it's taking some time because of the panel profiling. And here I will be using Penguin's data. So Penguin data is a data set, that has Penguin's uh, attributes. Penguins is like a bird. Okay, it's a bird, rather, it's a bird. Okay. So if you want to know how penguins is, just go to Google image and type penguins there. You see that penguins have gentle and so on and so forth. And the island where they are seen, we have Tongassen, we have so many islands here, and here are the attributes of the shape of those birds. This is their bill length, their bill depth, the flipper, how they, their wing, the flipper, the body, the weight in gram, and the gender, which is male and female. That's what the Bible said, male and female, God created them. Okay, so now if I want to understand, I want to group the data by the species. When I say species, you can see the species is all this one here: the gentle, the elderly, the chin strap. Okay, when I press enter now, you can see that this guy, I just apply, I use the group by method, and I put my variable there, that is species, and I apply. This is remember, what is the problem here? Mean type object or argument for how mean. Okay. What is the problem here? Language group by species dot mean. Why is it giving me problem here? Mm, okay. So it's saying that the argument function fail. How? Because we are using mean for the species, which happens to be an object. Remember, I said that you cannot be using the mean on something that is categorical variable. So that is what this guy is telling us here. So before, right, when you apply group by and say dot mean, so this guy will apply mean across all the numerical variables here. But I think Pandas, maybe the new version, they are now preventing that. So that is one of the errors that may occur when you have written a code for the long time and when they have released another version. So, but you can see that for me, I don't actually go to ChatGPT. I read the error. You can see type error, argument function fail. How mean? You can see how mean data type object. So this is what that one giving us. So let's see this one here. You can see that here now. You can see we apply the group by to be species. So the group by here. Remember this one is in the list. Remember, right? So this guy helps us to split the data. Okay, it helps us to split the data. You can see that it returns a group by object. So it tells us to split the data. Then from here now, we now apply the operation here. So here you can see the data that we want to use to get the average bill length is the bill length here. Okay, you can see this is the what do you call it now? This is the operation. Okay, look at it here. From the diagram, we have split. The group by will help us to split, and the apply is a function that we will now combine together. So that's exactly what this one is doing here. You can see the group by helps us to split the data. The bill length and the dot mean is what we apply, okay, and then combine it together. So if I run this guy now, we see that here we have the now to interpret this one now. This one means that the average bill length for a daily species is 38.8. The average length for chin strap is 48, and the average bill length for Gen2 is 47.5. What is this one telling us? This one is telling us that in the data, for the penguins, you will always see chin strap having higher bill length than other species, just like the way you always see a Igbo man be in a business compared to a Yoruba man in Nigeria. Okay, while you always see Yoruba going to becoming having more PhD than the Igbo. So data has shown, that I'm not just talking out of the data. Okay, so of course we can only group more than one variable. If I'm not correct, can you say yes on the chat concerning the Igbo and Yoruba in terms of the business? Okay, everybody saying yes. All right, thank you. So you can also group more than you can also group more than one variable. Okay, so in this case here you can see I group by two variables here, the species and the gender, the sex. Okay, and from there I now apply the numeric data that I want to carry my operation with. You can see here we have bill length. Okay, so you can see here now that for the Adele, right, the female Adele is the average bill length for female Adele is 27 279, okay, 2,791.7. This is the average bill length for Adele. Now for the male Adele, it is 3,028.3, and for the chin strap, you can see this is the average bean length for female. And now for the gentle, you can see the gentle, for the male Adele, it is 3,107.39. And the same thing for the female gentle penguins, it is 2,2642.7. Okay, so that is the average for the bean length for those species and their gender. You can see this looks like what we call in statistics contingency table, where we have they call it crosstab in social science. They call it crosstab. You can see here is species, here is the gender, and this is the value for those things. So that's all about the operation that involves you applying group by. Any question? Any question, please? If there's no question, let's continue. Okay. So the other thing I would like you to look at is, because I said that cross tab, okay, that is cross tabulation. So you always do this if you are a social scientist, right? You always like to, create a cross tab, and a cross tab could be 2 by 2 cross tab, it could be 3 by 2 cross tab, and that is where you apply what is called chi-square. If you always hear chi-squared, 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 go and use chi-squared. So this is where your chi-squared is coming from. Okay, now to create a cross tabulation, all right, you will use this function called pd dot cross tab. Remember the other time when we look at the group by, the group by is an attribute, okay, for pandas. But when we come to cross tab, it's no longer an attribute or a method. It is now a function on its own. So you can see, uh, okay, okay. So the cross tabulation operation, you need to use the function, from the pandas itself. It's not an attribute of pandas, but it's a function in itself. So now this is how it is. The structure is like this. you say pd.cross tab, the index, the columns, the value, the row name, the call name. These are all the parameters of the function. And the kind of argument function you want to use. Do you want to use do you want to count it? Do you want to put some? And the margin, okay? Margin is false. So the margin is, you can see it as a grand total. Grand total for the row, grand total for the column. This is where you specify it. Okay. So now you can see here is the breakdown of those parameters. The index is a series, value to group by in the rows. The column series is values to group by in the column. You can see the index is series, value to group by in the row. The column is series, value to group by in the column. Remember that cross tab is always by row and by column. You can easily understand cross tab if you look at, let me show you something here. Let me look at particular data, or let me use your own data here, and let me look at dataset data. Let me look at let me look at okay, let me look at the penguin data here. Okay, you cannot see my screen. I don't know why, but I'm still presenting. Okay. Okay. Can you see my screen now? Okay. Okay. Can you see my screen now? Can you see my screen now? Okay. So it is not my fault, or it is the what name of this software itself that is causing the trouble. It is the StreamYard that I'm streaming with. That is where the problem is. So let me stop sharing and share again. Okay, I think it should work now. Okay. Now, can you see my screen now? So it's loading. You will see my screen very soon. It is Yastic. It's not my own network. It's not my own computer. Now you can see my screen now. Okay. Remember that everything you are seeing on YouTube, I'm also seeing it here because I also open YouTube screen here so that I can see everything you are doing, and I can also see your chat at the same time. So I'm using two screens at the same time so as to help you. Okay, great. So for the cross tab, okay, I'm trying to open an Excel so that I can understand the concept of cross tab. Now look at this Excel sheet, right? It's still loading. You will see it very soon. Now the Excel is opened. So if you say cross tab, we mean a pivot table. Okay, we mean pivot table. So here, let me say I want to look at the species. Remember the species here, I put it under the rows feed, and then which one again? Let me look at the island. The island, I put it at the column feed. Okay. Now let's say that I want to look at the the number of female, the number here. You can see this is the gender, right? Look at it. I put the gender under the value feed. Now I can see the distribution of the what do you call it, of the species and the island. Okay. Now you are not seeing what this one mean. Then I can come to, I think I can come to analyze, and then I can come to design. and then click on the report layout and say show in tabular form. Now you can see that everything is now showing clearly. Now here is the gender, here is the grand total for the row, here is the grand total for the column. Okay, so this is what we call cross tabulation. Okay, and in statistics we can actually move further, right, by understanding if there's a relationship between species and where they are staying or where they are living. You can see here we have three islands. We have Bisco, we have Dream, and we have Togasen. Okay, so statistics now helps us to understand if the species, right, just for example now, you always see Yoruba in the western part of Nigeria. Why? We don't know why. Okay, you always see Igbo in the eastern part of Nigeria, and you always see many Hausas in the northern part of Nigeria because that is their base. So we don't know the characteristics that is making all of us to be where we are. It could be a particular attribute or characteristics which we have not been statistically proven, right? That makes us, for you now, you are in Lagos, another person is in which one again? Ogun State or your state or whatever. You know, we don't know why. The northern people too, they are in Kano, Benue, Nasarawa, and all of that. We don't know why. Okay, characteristics, that makes them to reside where they are. Okay, so statistics helps us to look at this further. If there's a relationship, we know that okay, if the chi-square, the p-value is less than 0.05, then you can tell us that there is a statistical reason why this and this are related. Okay, all right. So now let's see how we can create this kind of table with pandas. Remember, we have the index, we have the column, and we have the margin. Okay, you can see the margin here is true or false. The default is false, and what it's doing is just to add the grand total or call it subtotal. All right, now let's see. So now we say PD. We have known that cross tab is not a pandas attribute or method, so you cannot say dot cross tab. No, instead you say you use the function as it is. That is PD dot cross tab, and you can see the index is what will be in the row. Here we are saying it is penguins, I know, with the index species. You can see now here is the index. Okay, the column is what will be in the column. Okay, you can see here the column is gender. That is why we have female and male here. You can see now we say merging is equal to true. This merging helps us to get the subtotal, right? Or call it grand total. Right now, you can see 75 plus 75 is 150, 34 plus 34 is this. And for the female, you can see the female for all the species are 167. For male, it is 170, and the grand total is 337. So this is how to create a cross tab with pandas. Okay. Another one is this one here, where we are looking at the species and that of where they are staying, the island. Okay, and you can see that I say margin is true, just like what I did in the panda in Excel. The same thing I did it here. Now look at what I was saying. Look at gentle. You will never see a gentle penguins in the Dream Island or the Togasen Island. You can see you will never see, you just like you will never see a child of God becoming a sinner. The Bible said that no good tree will ever bear a bad fruit, and no bad tree will ever bear a good fruit. So this is it. Can you see now? And also for chin strap, you will never see a chin strap, staying in the Besco Island, or seeing a chin strap in what? In Togesin Island. Okay, so we can apply statistics just to know whether this is actually true, or we are just looking at it based on the data. All right. So it is time to go for a break. Let's go for a break for 3 minutes, and we come back. Today we will finish early today. So after this one, let me see the one that we can also look at. Oh yeah, so let's look at this one, and then let's see this one here. This one is concatenating. Okay, so we can look at Pandas 7 and Pandas 8 when we come back. Okay, you have your break now. As always, so if you have anybody staying with you, go and tell the person what you are learning. If it is your wife, just tell her that I'm learning Pandas and I love you. If it is your husband, say the same thing. If you are still waiting on the Lord, say, God, I am here. Bless me in Jesus' name. All right. Okay, Mr. Fable. Yeah. So on the use of IDE, we have so many IDEs in this programming. You have PyCharm, you have Jupyter Lab Notebook, you have VS Code, you have Spider, we have Positron, and many more. Okay, so which one? We also have Google Colab. So which one determines which one we should use? That is the question that this brother of God is asking. Of course, it depends on what you are doing. For example, if I'm using Anaconda Jupyter Lab Notebook, that one, as you know, it will work on the browser. So it will open a browser for you. Now look at me, that my house is not tidy. My browser alone, you can see I have so many things in my browser, so many things. Something that is even more than 1 year ago, you still see it on my browser. I don't know why. It is not a good habit, but I don't know why. I don't want to close it. The only way it closes itself is if my computer crashes by itself and I lost everything. I will not cry, of course. But for me to now close it, it's a big problem for me. Okay, so that means that whenever I'm showing something, maybe I'm having an executive meeting and I'm showing my boss or I'm showing anybody, they will see everything I'm doing. Imagine I want to resign and somebody is seeing another place where I just got a job. That will not be okay. So that is why you see that Google, what do you call it, Jupyter Lab Notebook, will not be a good one for somebody like me in that manner. Okay, because it has to open on the browser. Okay, of course, when the data is heavy, right, it will, I don't know, many people may not agree with me. It could affect your browser because your browser has its own limits. Okay, it has its own limits. And you know that whenever you open Jupyter Lab Notebook on the browser, there is a particular server working on the Anaconda, what do you call it now? Let me see. Anaconda prompt. Yes, there's a server working under this guy. If I open it now, all right, you see this thing will be running underneath. Okay, once you load the big data and you don't have much memory on your computer, then you may have a trouble. I may not be correct, but I'm just talking from my own experience. Okay, so that's all about Anaconda Jupyter Lab Notebook working on the browser. Now we now have VS Code. The VS Code is what I'm using. So if I'm applying for any job, I don't want any, and I'm presenting, nobody will see because I'm not working with the browser. Okay, you cannot see anything on my browser because this one is a standalone. It's not working with the browser, and this one has a lot of things. Number one, it has a co-pilot. Number two, it has so many languages that I can switch in when I'm using both R and I can see R here. both R and Python at the same time. Of course, terminal. I have terminal here, even with the VS with the Jupyter Lab notebook on the Anaconda distribution that also has a terminal. So that is that. But this one has, I think it has much more. Yeah, this one has much more. You can see it has much more. And here you can see I can switch to a folder. I can open folder. I can do so many things here. It also has autosave or whatever. Okay. Now we have another one called Google. We have another one called Google Colab. This one is from Google, and Google Colab is when you want to do collaborative data science work. For example, you cannot collaborate with me on the VS Code. Okay, you cannot collaborate with me. All right, but with Google Colab, you can easily collaborate because that one is in real time. Okay, it's in real time. You can collaborate. You can share your script online with people. If I want to share my script with you, I have to send it via email, or I share it via GitHub. Okay, but with Collab, you can share it online. Another thing is um Google Collab, right? Everything is working, is saving in your Google Drive. If your computer crashes, you can easily retrieve it back. This one, if it crashes, that is the end. Except I use version control, such as GitHub, to any work I do, just like I've closed my R programming. Except you are committing and you are pushing your changes. Okay, that is where you will not lose anything. Okay, with that. What other thing? I think that is all. I hope you understand it now. So what and what can you use depend on you, and please don't be asking it again that which one can you use. It depends on you. If I like me, if I want to use R programming, I will use the R Studio. Of course I can use the VS Code, but I have a brother. My brother will never use R Studio. He has been telling me to use VS Code for so long, but now when I started using VS Code for Python, I was like, this thing is good though. And my brother have been telling me all this thing for a long time. I will not listen. I just tell him, Oga, I don't like wahala. Just let me be using my house to do JJ. But now, if I want to do anything on Python, I will use VS Code. If it is R, it's either I use the R Studio or I use the Positron. So this one too is another IDE. Positron, okay, is the how will I call it, they clone it from the VS code. They clone it from the VS code. You can see it looks like VS code because it's a clone of VS code. But this one is actually from R Studio. They developed this one to help us navigate to data science. It has almost everything. You can see everything you can do. For example, my book that I'm writing, you can see if I come here, the book, all right, and I click select folder, everything I'm working with will be, yes, I trust the author, yes, allow, okay. For each lab is here. You can see my code here, okay, that I use to render the book. You can see. So this is everything now. And the same thing can also be done with VS Code. So that's all about that. Now let's go back to our class. Any question? Meaning Google Colab is better. Yes, it is better. But one thing, number one, it will chop your data. And many people in Nigeria, they always cry of data. So Google Colab will chop your data. Another thing is you don't need to actually install anything on your local drive, because whatever you are installing, you are installing it on server. So that is all about that. But will you always be online every time? The answer is no. Okay, so that is why except you are doing some, let's say you are doing something on cargo. Of course, Google Colab gives you about 15 gig RAM free of charge. Okay, And if you don't have money, you may not have such kind of laptop with you. All right. But Google Colab gives you for free, gives you for free. All right. But for me, my laptop is 16 gig RAM, is NVIDIA, it has NVIDIA GPU, 1 terabyte. It's a very big computer, and also I don't need collab because I don't want anything to chop my data. Okay, everybody's managing data in Nigeria. All right, so that's all about that. Any question? Can I install pip-wide data on collab? Yes, you can install it. Yes, you can install it. VS Code is better based on what I have said. Yeah, yeah. It depends on you. If you like. Before I used to use Jupyter Lab, Anaconda Jupyter Lab notebook. Okay. But because of my browser, it will be opening. Everybody will be seeing what I'm doing on my, for example, now. Look at this one, for example. Wait. Uh, uh, for example, if I open Jupyter Lab notebook now with Anaconda, it will open here. You can see, and yeah, I like all the article I'm reading. You can see several articles I'm reading, and many more like that. Okay, so that's just people will be seeing what you are doing on your browser, but VS Code, nobody will see what you are doing. Okay, Anaconda takes time to load. You are correct. So of course, it also depends on your laptop, and then it depends on how you are opening it. Remember, we have said in this class that you should not open Anaconda with Anaconda Navigator. Instead, just say, look at it now. Let me use my computer. So here I say Anaconda prompt. Can you see Anaconda prompt? Okay, Anaconda prompt. It opens. Now I can say Jupyter. So it will not take my time. I can see Jupyter Lab. So let's be counting it. So let me have my clock here so that I can know that it's not taking time. So if it takes your time, then it depends on your laptop. So I want to do stopwatch. You can see stopwatch. So can you see my screen? So can you see my screen? So now you can see I'm using this Anaconda prompt. So this is the time. So I just time it now. So you can see, let's see how long it will take me to open. So it's loading. Okay. You can see. Now it has opened. You can see now. So the time that it takes to open is still loading. It's still loading. So I've spent 21 seconds. It's still loading. It's still loading. So you can see now. So it opens at, let's say, 30 seconds. Can you see? So it opens at 30 seconds, and I can open my Python kernel or my folder. I can come to my folder and come here and look for my is under I don't know where does it this one where did I save it? I save it under um uh under the desktop, temporary new, under the desktop. Okay, temporary new T, temporary new, this one, and then snippet for code 2. So you can see now. So you can see I'm in Pandas 6 or 7. So this is my Panda. You can see now. All right. And yeah, you can see now. I can do everything. So it's even having share. Can you share my notebook? So they just integrate this one. So I have to log in. Wow. I have to log in. You can see it asks me to log into Anaconda distribution. Then I can start sharing. Okay. So you can see that it only takes me 30 seconds to open. So somebody Joseph is saying that 30 seconds is fair. You can see now. Okay. But the VS Code, how long will it take us? So let's look at the VS Code. So I'm just opening VS Code here again. This one will not take us many minutes. You can see it has opened. You can see it has opened, and then you just go to your open folder and then look for the code snippet and click open folder, and you have it. So this one can take you 5 seconds. All right. So my system is high. Yeah, of course, my system is. Yeah, I bought it with a lot of money. Jesus bought it for me. Okay, if you look at my system information, for example, you can see what is it? You can see I have that 30. I have I have my total memory is 31 gig. Install memory is 32 gig. Okay, 32 gig. What other thing is? Uh, it has NVIDIA GPU. It has so many things. So the my computer is XPS 15. Okay, it's very expensive. You can see the processor is Core i7. You can see the all this kind of configuration. So now let's go to Pandas. Okay. Let's see. We have done this one. Another thing is Pandas 7. So in data science, so I will have about 10 minutes to walk you through all these things. It is not uncommon to combine data together because your data for your analysis will not be in one file. It could spread across several files, and it is your own cup of tea to combine those data sets together so as to have a single source of truth that will help you to analyze your data. All right, and we have several methods at which you can combine your data together depending on the scenario. Of course, we have two scenarios. The first scenario is this. I want to start an example based on my experience in COVID-19 pandemic time at COVID-19 time period. Remember, let's say you have you are working with NCDC, all right, for Oyo State. You have another friend working at NCDC. All of you are about 3 people working at NCDC. Okay, we have about 14. We have about 4 zones in Nigeria: the North Zone, the West Zone. We have about 6 regions in Nigeria: the North, North South. Let me plot my what did they call it? North, East, South, West. Okay, you have Northeast, you have North, which one? Northeast. Oh my God, let me Google it. Uh, how many we have geopolitical zone, right? See geopolitical zone in Nigeria. We have how many geopolitical zone in Nigeria? So we have 6 geopolitical zones, right? We have North Central, we have Northeast, we have Northwest, we have Southeast, we have South South, and we have Southwest. All right, great. So now let's say that for each zone we have data manager, and I'm so happy that Elizabeth is one of them. We have Elizabeth as one of them. We have Precious as one of them. Joshua as one of them. We have Tony as one of them. We have which one again? Azan as one of them. So they are all 6, and all of those data managers are from this training. I'm so happy that they are from this training. Now, let's say that all the data managers have collected the data by their zone. Now you are the overall managers, and you want to combine those data sets together. Remember, you have data in North Central, Northeast, Northwest, Southeast, South South, and Southwest, and you collected the same variables. In that case, to combine that data, we will be using what we call concatenation. Okay, we'll be using what is called concatenation. Okay, we'll be using what is called concatenation. You use pd.concat to be able to combine those data sets together. It's very simple. So let me just go there now. You can see here we have COVID-19 in the East Africa, we have COVID-19 in Central Africa. Okay, and to combine them, you will just say, can you see say pd.concat and you create a link, and that's all, and then you combine it. You can see, so before we have data from East Africa and it's 5 in number. We have data from Central Africa and it is 5 in number. And when you available, so okay, let me import the data. Let me import the import pandas as pd, import okay numpy as np. Okay, import numpy as np. So it's running. Now you can see that I have the package imported now. Okay, so please, can you see, can you still hear me? Everyone, can you hear me? Am I audible? Okay, thank you so much. So now I imported the modules. Now this is the first data, okay, and I want to create a shape for it. So that is, it will be East Africa COVID dot shape, okay, just to get the dimension of the data. You can see here we have 19 of 19 COVID-19 cases. Here we have Central Africa, COVID dot shape. Okay, so here we have 9. Okay, I can see that the two of them have the same number of columns, and the number of columns are actually the same because those are the, before you can combine them together, they must have the same columns. The column must be the same in terms of the names. Okay, the names must be the same, the number must be the same. Okay, so here now I can just say East Africa COVID-19 dot column, for example. The columns you can see here and here, and then for this one too, I can say Central Africa COVID-19, then dot shape, the same thing. You see dot shape or dot columns. Okay, you can see they are the same. Okay, now you may even ask whether these guys are the same by, you can ask whether they are the same by just saying this, uh by just saying okay, this is this one equal to this one, and let's see what it will return for you. Okay, you can see that everything is the same. You can see now that they are the same. Okay, so now to combine them, you just say pd.concat and you put those data frames in a list and you run it. Immediately you run it, you see you now have combined data sets. Okay, everything lie to their columns. You can see. So that is all about that. And then when you are combining, okay, so each data frame will come with its own index. Remember, you are just putting, for example, now Abigail is a female, and Abigail is carrying fever, for example. You can see. So Abigail will come with her surname, and favor too will come with her surname. So, but yeah, that is what this guy is doing. The index, everybody, the first data is carrying its index. The another data set will also start with 0, and I can see come with own index. So to reset those index, then we now say ignore index is equal to true. So if you say this, then the index will be reset and everything will start from zero and continue until the end of the data frame. So that's all about PD, the concat, which helps us to combine the data at the same time. The same thing we are doing here. Here is another example from North Africa, all right, and we try to also combine it by using this list you can see. So here we have North Africa, East Africa, and Central Africa, okay, and we say ignore index, then we now have everything. So that is the first way at which we can combine data set. Any question? Are they in terms of the columns? Yes, I've said it before, Mary. They must be the same. And we actually tested it. If you look at it, in the first example, we look at the columns. Here is the column. Okay, we got this. And for the Central Africa and East Africa, we do the same thing. And from here, we try to check because you must check whether they are the same. So here we check it by using this guy. Okay, and you can see that everything is true, meaning that all the columns are the same in terms of the name, in terms of their names. Okay, so then and we are happy to combine everything. Okay. Precious, you are saying no, what happened? Okay, no question. All right, thank you. Okay, so let's continue. All right, now we are moving to the last one here. So that is merging data sets. So what is merging? Merging, of course, in English, it's like you are putting things together. All right, but we actually do it in a different way. What do we mean? So let me see if I have a good example to explain this. Uh, oh, I need to use slide here, but let me look at these materials to help you. Uh, do I have the slide here to explain merging so that I can understand merging? Uh, that is data science resources with Python, CS2, resources, uh, slide, importing data. Oh my God. I don't have that slide, but let me see this guy. Okay. Let me see the material for this one here. DAVR material, that is advanced data. You see this one? Let me see. Uh, let me look at this material. Okay. Okay. Let me look at this material. Okay. So are you still with me? By 8:50, we must finish this thing. Are you with me? Can you see my screen? My screen is not loading. Okay, you can see my screen. Okay, you can see my screen. I don't know. Is this guy or the Yastic is the one doing the wala? Okay. Okay, it's loading. The stream yard is the one causing this trouble. So you should see my screen now. Okay, it's still loading. It's still loading. It's not my network. It's not my computer. It's the software that we are using to stream that is causing this trouble. Okay. I don't know why this guy is not. Okay, okay. You can see my screen now. Okay. So don't worry about this slide though. I just want you to quickly understand what this guy is all about. Okay. Um. Okay. In the merging of data sets, right? As I said before, that data can come from multiple sources, and you need to combine them so as to be able to apply to be able to get insight from them. Okay. So in pandas, right, we have about four merging type. Okay. We have inner join, we have left join, we have right join, and we have full join. So what do we mean by inner join? So inner join, what it does is to help us keep only row where we have matching key, in both data sets. It's just like an intersection, okay, between the two. Okay. Now we have left join. So the left join, remember we have two data sets and we want to left join. You will see everything in the by using pie chart very soon. Okay. So the left join will keep every column and the row in the first data and now combine it with second data where where it will combine the second data. Okay. If there's no like where the foreign key or the primary key where they match, that place will become it will return missing value or null. The right join is doing the same thing. You have, okay, let me explain with this guy. First, let's understand what is primary key and secondary key. Before you can merge data sets together, they must have a particular column, right? Which helps us to identify. For example, now, if I want to know everything about you, just give me your NIN or your BVN. I will know everything all about you. I will know your gender. I will know your account balance. I will know all the banks you have taken loans. I will know whether you are defaulting in loan or not. I will know almost everything. I will know your house address. I will know everything about you. That is why it is good to always keep our BBN safe. Okay. So the key that will help us to uniquely identify rows in a data set is called a key. Okay. And these two forms, we have primary key. Remember, we have two data. Let's call the first data data A, the second data B. In the first data, that is where your primary key will be. And there must be a particular column that uniquely identify your data. It could be your BVN, for example. It could be your student matric number, a member in school. If you offend any lecturer, what they need is just your matric number. That's all. Okay. Good. Now, what is foreign key? In that second data, right, where the column, right, where a particular column that represents what is in the first column, that is your primary key, is what we call foreign key. And you will understand it in the data. For example, look at these two data sets. The first data set has student ID and the name. All right. The second data set has the same student ID but with score. You can see that the data sets are different, but they have something that relates them with each other. You can see student ID here. You can see student ID here. So if I merge data set, then I will now look at which method. And in Python, the parameter to merge them is called how. Okay, just note it down. Look at this. So in the inner join will merge the two data sets, but we only keep only rows with matching key in both data sets. You can see. So where the data set has something in common is what this guy we put together to have your merge data set. Okay, for example, look at this one here. You have student ID and you have another ID here. Now you want to merge the data set together. Why are we doing merging and not doing and not combining? The data set do not have the same information. You cannot just put everything here. Be omo bafun or soon. Okay, so you cannot put the two data together except you merge them. And we are using inner join here. So in inner join, you can see, do you have one here? There's no one. So in the resulting data set, the one will not occur. The information for one will not occur. But there is ID2 here. There is ID2 here. So when you match them, the two information will come from the two data frame. You can see the same thing here. You can see we have ID3 here and we have ID3 here. So therefore, Charlie will come. You know, information for Charlie will come. So that's all about inner join. We also have a left join. So the left join is combining all the rows from the left data, which is your data A, okay, and then combine it with the data in data B. But wherever the merge appear, then the score will appear. So if the merge is not the primary key could not see the foreign key, in that case there will be missing value. So that is what we have here. You can see ID1 is here, ID1 is not here. That is why it will throws NA for score. ID2 is here, ID2 is here. You can see the full information comes out. ID3 is here, ID3 is here, the full information come out. But when it comes to Diana, ID4 is here and ID4 is not here. And remember the left join is combining every information in the left data and only combine the data where the primary key could be seen in the foreign key. So the first data, this is your primary key. In the second data, this is your foreign key. So where they match is where the data will come. Otherwise, it will return an NA. Now we now have another one called the right join. So in this case, the right join will be doing exactly what the left join is doing, but in the right direction. So your right direction is here. So all the information here will be kept, while it will only match where the information is in the left. So where there is no information, it will throw an NA. You can see NA is here because there is no ID5. There is no ID5 in the right join. That is why the NA is coming here. And we have the full join. The full join is doing combination of everything. Whether they match it or they don't match it, you just combine every data together. Okay, but it doesn't work like a combine. It must still work. It must still look at the ID to see. You can see every information. You can see here. If it matches it, then it will throw the information. Otherwise, it will still throw NA. But every information must come because see, this one is 1, 2, 3, 4. This one 2, 3, 5, and you can see everything. It has a combination of everything. But where there's no match, it will throw an NA. That's all about that. Any question from the PowerPoint? Any question from the PowerPoint? Any question? Hello, any question from the PowerPoint? When do we know when to merge or concatenate? Remember, I've already told you. So if all the columns are the same, in that case, you will do concatenation. If all the columns are not the same, okay, but you can see your primary key in the first data and the foreign key in the second data, in that case, you will do merge. Okay, now let me show you an example. Now you know left, right, you know all of this. So the parameter on is the column that you want to join with. This is your primary and your foreign key. The arrow is the kind of join you want to do. Is this left join? Is this right join? Is it outer join? Okay. Is it inner join? We have inner join. You can see inner join is that of the one that combine the intersection. Okay. the left here, the right here. So the outer here is the full join. Okay, and this is an example. In the first data, we have the COVID-19 information. Hallelujah. And I'm trying to import the data. Okay, so here's is my data. Okay, telling me that. Uh, so let me import the package. Import pandas as PD. Okay. Yeah. So now I just run this guy. The COVID-19 data is not defined. Okay. So this one is COVID-19 data. Okay. Let me just copy it here. Now I can see that everything works now. Yeah. Oh my God. What happened? We have any everywhere. Uh, COVID-19 data, country, total cases, total deaths. Uh, okay. I'm sorry. I think I have a problem with this naming here. Okay. Total cases, total death. Okay. Total recovered. Okay. And the population. So if I run it now, everything should work. You can see it works now. Please imagine, in case you are doing your own and you are getting an error. Remember, I just corrected the error now. Don't tag me on the group and saying that my script is not the same as yours. Okay. So here is the epidemiology data. Now you can see we are having two data sets here. The first one is COVID-19 data. I can see the data frame. It has all the information about COVID-19. So now here is the epidemiology information that has the fatality rate, the discharge rate. And you can see, look at it here now. In this data, we have country. And the country is our unique key that identify the information about those countries. Yeah. And here too, we have the same data called country. So sometimes the column may not be the same, but the information will be well represented. For example, I can call this one country, I can call this one nation. But you can see that here we have Burundi, and here too we have Burundi. Okay, you can see if I call this one country, if I call this one nation, and I call this one country, it's still the same thing. Only that they don't bear the same name. So it will still work. So far, the foreign key and the primary key are available. You have no problem. Okay. So now let's see how to do it. I've told you about primary key already and the foreign key, and then you now use pd.merge. Okay. So the left join is the first, the left when you are using left join, then it will consider everything in the first data set and then only combine the data set in the right where there is information, that uniquely identify the left and the first data, second data. I've already explained all these things. The on here is the column you want to join with, and the how is how you want to join it. So now let's continue with this guy. COVID-19 data, COVID-19 information, for example, COVID-19 information DF. Okay, so if you run this guy, we have just 1 minute and we do it. COVID-19 is data is working, this one is working. Now you can see to merge it. Here you use COVID-19, you can see the first data frame, the second data frame on. I want to join which column that will uniquely identify my data, and that column is country. You can see how do I want to join it. I want to use left, and then I run it like this. You can see that now I have everything. Where there is no information, then it will throw an N. You can see there is no N here because every information, every country has its, so every country in the COVID-19 is also in the epidemiology. That is why every information, comes out here. In the second example, I have bad member. You can see the name. I have another one, bad instrument, and then you can, here I want to use inner join. Inner join, we look at where I'm using the name. You can see where we have the name together. You can see Mike is here, Mike is not here. So that when we are using left join, okay, here we are using inner join. So it will only take where the data, where the data is common in the name. You can see Mike is not here, Mike is not here. John is here, John is here. Therefore, John will come out. Okay. Paul is here, Paul is here. Paul will come out. And that is why we have this. You can see. Okay. So the same thing also happened to the left, and the same thing also happened to the right. And for the outer join, so to combine the data set together from the left and from the right. Thank you very much. And the Lord is with us. Hallelujah. Any question? I'm done. Any question? Any question? Is it possible to concatenate? Is it possible to concatenate one DL with two columns with another with 5 columns but have the same number of rows? So if you do that, where the columns are not the same, right? It will throw an NA in those columns. So it is possible, but remember that it will throw uh, NA, right, where the columns are not the same. So full join is simple universal in the way it functions. Yes. So the full join will combine every row, in the data set. Column with another with 5 column, but we have the same number of rows. I'm not getting what you are saying. Bamidele, we will okay. Please, can I get the link to this class on your channel, sir? It's better because I notice you take your time to explain on the channel. Yeah, you are correct. I take my time to let me send to you again. I take my time on the channel because there is no 1 month, 2 months notice, right? In the channel, if you like, you can spend 5 years on it. Uh, Let me send it to you again. So the reason, of course, I'm not too fast here too, but we have to complete all our materials, and I believe that you understand everything. So I just sent you the link now, so you can look at it, and this one too, you can come back to it and watch it again. So we are now done with Pandas. Okay. If there's anything you want to learn in Pandas, I believe we have covered it here. Okay. And if I were you, I will go to cargo, look for a particular data, and start applying everything I've learned in data analysis with Pandas. So tomorrow, by the grace of the Almighty God, we will look at data visualization with Matplotlib and Seaborn. Of course, we focus mainly on Seaborn, okay, because Seaborn was built on Matplotlib. All right, and Seaborn is actually strictly to work with Pandas data frame, but we'll be using some other function in Matplotlib, for example, to rename our label, and many other things like that. So please ensure that you have Seaborn, installed already. If you have not installed it, or if it does not come with your Anaconda distribution, make sure you install it. And I pray the Almighty God be with all of us and increase our knowledge in Jesus' name. Amen. Bye bye.